Hello everyone, and welcome again to the coding channel. In today's video we're going to see one of the most common coding questions that maybe most of you have already heard about this. I'm talking about the Fibonacci sequence problem. Let's not waste any more time and let's get started. The Fibonacci sequence is a sequence where each number is the sum of the two preceding ones, starting from 0 and 1. That is, function of 0 is 0, function of 1 is 1, and function of n is a function of n minus 1 plus function of n minus 2. So the only known numbers are 0 and 1, and all others have to be calculated from them. The problem asks us to write all Fibonacci numbers from 0 to n, where n is an integer received in input. Here we have an example. For input 4, the expected output is 0, 1, 1, and 2. And for the input 12, the expected result is 0, 1, 2, 3, 5, 8, and so on. The first approach that we can try is to apply the formulas as is. So for example, with input 4, we can substitute the number in the function Fibonacci of 4, that is Fibonacci of 3 plus Fibonacci of 2. But Fibonacci of 3, again following the formula, is Fibonacci of 2 plus Fibonacci of 1. And again, Fibonacci of 1 is equal to 1, and so on. At the end, if we do all the additions, we get the result 3. We can repeat these functions for all numbers starting from 0 to n. Here we have the code, a main function that loops starting from 0 to n, and a second function that computes the Fibonacci numbers as we have seen before. Unfortunately, each call of the Fibonacci function takes complexity of 2 power n, and if we sum it for all the numbers that we have to compute, the total complexity of the algorithm is 2 power n. If we return at the explanation of the algorithm, we can notice that some calculations have to be repeated more times. For example, the Fibonacci of 2 is repeated 2 times. And think about if we grow with the number n, how much time we have to repeat the same calculation. But if we start from 0, we can easily save the already computed values and reuse them when we need it. So let's try in this way. Fibonacci of 0 is 0, and Fibonacci of 1 is 1 because are given. When we have to calculate the Fibonacci of 2, we have to sum the Fibonacci of 1 plus the Fibonacci of 0 that are both given, and the result is 0 plus 1 equal to 1. We can now save the result in a generic array, saving at position 2 the value 1. If we try to calculate the Fibonacci number of 3, we need to know the Fibonacci number of 2 and the Fibonacci number of 1. The last one is given, and the first one, we already know his value because it is stored in the array at position 2. So we can calculate the result and store it in the array again. The same happened with Fibonacci of 4 because we already know the values of Fibonacci of 3 and Fibonacci of 2 because we have already stored them in the array before. And we can proceed in this way until we reach the end of the for loop. The differences with the previous algorithm are only the array, where we store the calculated values, and the reusage of them when we need it. If we look at the complexity, the function that computes the Fibonacci number, this time, takes only a constant time, because for each iteration, we already know all values that we need to do the sum. Considering that we have to repeat it n times, the total complexity of the algorithm is big O of n, so it is linear. Looking at the graph, it is evident that the first algorithm is very bad compared to the second one. The exponential complexity is something that we have to avoid much as we can. If in some problem you get a complexity like that, think about that more or less always there is a more efficient solution. Today, before the conclusion of the video, I want to leave you a tip. When we have an exponential time with the recursive algorithms, try with the memorization technique. In most cases, it is enough to get a more efficient solution. Okay, thank you guys for watching, and as usual, if you have any question or any suggestion, please let me know here in the comments below. Thank you again, and see you soon in the next video.